Myself Ajay Mukherjee. Today we have to discuss class 12th chapter 5 continuity. First of all, I am telling you define of the continuous function. For this, f is a real function on a subset of real number. It means here f is a real function and any number belongs to this function is always real. Let C be any point in domain. C, we are taking the C is a point. Domain means we have to put a value into the function, then f is continuous. For this I am telling you how it is continuous by this limit extending to c fx. Limit extending to c fx is equal to fc. Means if we have to put the value of x is equal to c, when you put the value of x, it is behave like a domain. When you put the value of c into the function, we get answer is the function of c. It means this value is always real. Into the function, this is fx is the function. If you put any value c in the function and the value c put into the function, our answer is also in the function of c, also real, then function is called continuous function. For this I am taking a question number first. The function of x is equal to modulus x. This function is always continuous function for all points. So first of all I define this function. This is the function. Define I am taking fx is equal to y. So let y is equal to fx, and now I am define the function. Modulus x is either it is negative or it is positive. Discuss on to the 0. Function is defined at the 0. If we are going to the left side, then always value is negative, and if we are going to the right side, the value is positive. So function is defined as a left hand limit, as a right hand limit. When we are going into the left hand limit, this x is equal to behave like a negative, so we are taking minus x. And when we are going into the right hand limit and this x is behave like a positive, so we are taking x positive. In left hand side, negative x if x is less than 0, means if the value of x is less than 0, then x is equal to negative, and x is greater than 0, then this x is behave like a positive. So we have now we have defined this function. By this function we are making the two tables for drawing a graph. Here is x is less than 0, x we are taking the 2 point, one is x and other is y. The x is equal to, this is given here, x is less than 0, it means x is less than 0, minus 1, minus 2, minus 3, these value less than 0. When these value put into this here in this function, minus 1 put here, this is already minus and minus 1, this is the plus 1. When we put here minus 2, already negative is there, plus 2, and minus 3 also get the 3. Same as when we put the x is greater than 0, value x is greater than 0 means greater than equal to. When we have put the value of x is equal to 0 or more than 0, 0, 1, 2, 3. Here you put the value of 0 here, you get answer 0. Put here 1, answer is 1. Put here 2, answer is 2. Put here 3, answer is 3. So by these two tables we have to make a graph. 0, here is positive x, negative x, y dash, we are taking the point 1, 2, 3, negative, minus 1, minus 2, minus 3, 1, 2, 3, and minus 1, minus 2, in the downward direction. X is equal to minus 1, y is equal to 1. First of all, x is equal to minus 1, y is equal to 1. Here is x is equal to minus 1 and y is equal to, this is 1, minus 1, 1, this point we get. X is equal to minus 2, y is equal to 2, this is minus 2, 2. Same as the minus 3, 3. We get these point 3, 1, 2, 3 points. Now we discuss this table. X is equal to 0, y is also 0. This point is equal to x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 1, x1, here is y1, x1, this is y1, this point, x2 and y2, this point in front of x and in front of y, same as x3, y3. When we are making the graph we have to made by this with the single hand. If you are making the graph with single hand, in the single time, without picking your hand, you can make this graph in this situation function is called continuous function. Suppose you are making the graph in this way, this is the one time and now the second time. This is not a single hand graph. In this situation function is not continuous. This is the by the graphical situation we can handle this situation, the function is continuous or not continuous. And now we discuss on to the question. Here is the 3 point we discussed by define x is less than 0, x is greater than 0, x is equal to 0. 3 times we check the function is continuous or not continuous. First of all, let's check x is equal to 0. We have to check the function at x is equal to 0. At x is equal to 0, we are taking 3 limit. One is left hand limit, other is right hand limit, and third one equal to limit. So first of all, we discuss now the left hand limit. Left hand limit x tending to 0. We are taking the negative sign. This negative sign means we discuss on to the left hand limit. Limit x tending to 0 negative, function fx is equal to limit x tending to 0 negative. For left hand limit, here we discuss x is less than 0 means this is the answer minus x. X less than 0 means left hand limit, the answer is minus x. So write down here minus x. And limit x is equal to 0, put here value of 0, we get answer is 0. Now we discuss on to the right hand limit. Limit x tending to 0, 0 positive sign is there, upper side of the 0, it means we are discuss right hand limit. Fx is equal to limit x tending to 0. For right hand limit, look at this, x is greater than 0. Here is x is greater than 0. So right hand limit we can take this answer x. Write down here x. Putting the limit into this value, x is 0. If we put here 0, the answer is equal to again 0. Now we are taking the equal sign. Limit x tending to 0, fx is equal to limit x tending to 0. Look at this is the equal sign. Here is a lower part, this is equal sign. When you are taking equal side, answer is equal to again x. So put here x. And now replacing the limit 0, so answer is equal to again 0. 3 times we get 0. It means left hand limit, right hand limit and equal to limits are equal. So function is continuous at x is equal to 0. For at x is equal to 0, we discuss it into the 3 times. Left hand limit, right hand limit and equal to. In these 3 conditions, left, right and equal, these 3 are equal, then we can say the function is continuous. Now we discuss on to the 2 more conditions also. This condition is equal to x is equal to 0. Now the 2 conditions when x is greater than 0 and third condition x is less than 0. Now this is the x is equal to c greater than 0. The first condition at x is equal to 0. Now the second condition is this. At first condition we discuss 3 cases. At second condition x is equal to c greater than 0. Second condition x is equal to c greater than 0. So limit x tending to c. C means that c is a behave like a real number. C behave like a real number. Limit x tending to c fx. Limit x tending to c. And now the value of the x is equal to c greater than 0 means that x is greater than 0. Here is x is greater than 0. We can take this answer in this situation. So we are taking x and now putting the value of c. C you put here by x. So we get answer c. It means the answer is equal to real. If our answer is real, it means function is continuous. Now we discuss on the third case, x is equal to c less than 0. Now the second case is equal to x is equal to c greater than 0. Now x is equal to c less than 0. Limit x tending to c is equal to limit x tending to c less than 0. Look at this, x is less than 0. So we are taking this answer minus x. Here also we are taking minus x and replacing the limit c in this position. When we replace the c, we get minus c and minus c also real. So the function is real. So 3 conditions are there: 0, greater than 0, less than 0. In these 3 conditions, function is continuous. So no point of discontinuity for this function. Now one more question also I am telling you. For the discontinuity point, the function is given modulus x plus 3 if x is less than equal to 0, minus 2x if x is greater than minus 3 less than 3, and 6x plus 2x is greater than equal to 3. So first of all we have to discuss at x is equal to minus 3. when we check it into the x is equal to minus 3, we discuss 3 cases. First at x is equal to minus 3, we discuss 3 cases: left hand limit, right hand limit, and equal to. So we are discussed to the left hand limit, limit x tending to minus 3, negative sign is upper side, it means we are taking left hand side, left hand limit, fx is equal to limit x tending to minus 3, negative sign, and values of left hand limit is equal to, look at this, x is less than minus 3. Here is condition, x is less than minus 3. Here is x is equal to minus 3. So for left hand limit we are taking this answer modulus x plus 3. But I am taking here minus x instead of modulus x, because left hand side modulus x is always negative. Here is a, in left side modulus x is equal to minus x. Here is a modulus x and it's always negative. So in left hand side, so modulus x replacing by minus x plus 3. Now we are putting the limit minus 3 here, negative sign is always there, minus plus 3, and plus 3 we get 6. Now we discuss on to the right hand limit, limit x tending to minus 3, positive sign for right hand limit, fx, look at this is right hand limit, here we take the right hand limit, x greater than minus 3, our answer is equal to minus 2x, so replacing here minus 2x. X is replacing by minus 3, here we put minus 3, minus 2 into minus 3, we get answer is equal to 6. Now discuss on to the third, equal to limit, limit x tending to minus 3, fx is equal to limit x tending to minus 3. For equal to, here is minus 3, here is equal to sign, we are taking this complete value, modulus x plus 3, we are taking modulus x plus 3. And replacing by value is minus 3 here inside the modulus, and always answer is positive, 3 plus 3 we get 6. Here I am taking only value of modulus in negative, but here I am taking the directly modulus, because if this is the left hand limit, and left side always modulus behave like a minus define of modulus. Here minus x by the define. So here we are using the define, and here directly limit is equal form, not left and right. So directly I am putting here modulus x. Now the two more cases are discussed about x is equal to minus 3. Here I am taking x is equal to c greater than minus 3. For this limit x tending to c, c is a real number, limit x tending to c, fx, limit x tending to c. At the left side, x is equal to c greater than minus 3 means, x is greater than minus 3 means we are taking this value minus 2x. So here it is replacing minus 2x, and limit is equal to x is equal to c, so x is replacing by c, so answer is equal to minus 2c. 2c means this is answer real, so real answer means this is the continuous. Now I am taking one more situation, x is equal to c less than minus 3, limit x tending to c, fx, limit x tending to c. For left side, for minus 3, x is equal to c less than minus 3. Here the condition is equal to at x is minus 3 less, for we are taking this modulus x plus 3. But in the left side, modulus x, inside the x behave like a minus x plus 3. So x is replacing by c, so answer again minus c plus 3. This answer is also real, so function is continuous. Every point at minus 3 equal to, greater than, or less than, in these three conditions function is continuous. Now we are discuss at x is equal to 3. At x is equal to 3, left hand limit is equal to limit x tending to 3, negative sign is taking here function fx, limit x tending to 3, negative sign. At the left side, x is less than 3, here situation is equal to x is less than 3, left hand side we are taking from this situation, the answer is minus 2x, so write down here minus 2x, and x is replacing by 3, minus 2 into 3 we get minus 6 answer. At the right hand limit, at x is equal to 3, right hand limit, limit x tending to 3 plus fx is equal to limit x tending to 3 plus, for right hand limit, look at this situation, x is greater than 3, so at x is equal to greater than, right hand limit always greater situation, so x greater than 3, but for right hand limit this value we have to put 6x plus 2, and x is replacing by 3, we get our answer is 20. Now in this situation, left and right are not equal, so we don't check the third limit equal to, two limits are not equal, so function is not continuous at x is equal to 3. Now two more situation also there. X is equal to C greater than 3. Yes, this situation also we are taking X is equal to C greater than 3. So this situation we handle here. X is greater than 3. So this we are taking this for this limit. This value we are taking for this limit. So we are replacing by X is equal to C. In this situation we get answer 6C plus 2. In this situation our answer is equal to 6C plus 2. This is also real, so function is continuous. One more situation also there. X is equal to C. This is the greater than equal to less than 3. Then less than 3, here is X is less than 3, and we are taking this answer minus 2x, and when you put the limit here you get minus 2. This is also real, so function is continuous. Only this situation the function is not continuous. This is the point for discontinuity. So that's all students for the today.